This video covers the Lesson 2-2 warm-up for Secondary 1 Math, writing and interpreting linear equations in one variable. Aubrey and Caleb are on the yearbook staff. They have been assigned to find facts about the students at Oak Canyon Junior High. They created a table to help them organize their data. So notice on the left side of the table, they have a variable, and on the right, the meaning. So, for example, the variable t represents the number of teachers at Oak Canyon Junior High. If you go down to like C, C represents the number of classes offered each period. Or H would be the number of 7th grade boys attending Oak Canyon Junior High. And N would be the number of 9th grade girls attending Oak Canyon Junior High. So we're going to use this to describe what expressions represent and write expressions. Number 1, what does B plus G, all divided by C, represent? Looking at our table, we know that B represents the number of boys attending Oak Canyon Junior High, and G represents the number of girls attending Oak Canyon Junior High. So together, if we take all the boys and all the girls attending Oak Canyon Junior High, that represents all the students, or all the students at Oak Canyon. So the number of students. And now we're going to divide this by C. If we look back at our table, C represents the number of classes offered each period. So we're going to get the number of students over the number of classes, or the number of students per class. We can write it that way. In words, students per class. And we really should say this is the average number of students per class, since not every class will have the same number of students in it. Okay, number 2, what does y plus n minus z represent? Well, looking back at our table, y represents the number of 9th grade boys at Oak Canyon, and n represents the number of 9th grade girls attending Oak Canyon, and z represents the number of 9th graders enrolled in biology. So if we add up y and n, the number of 9th grade girls and the number of 9th grade boys, that's going to give us a total number of 9th graders, or all the 9th grade students. Now we're going to subtract z. And what are we subtracting? We're subtracting the 9th graders who attend biology. So what do we get when we take all the 9th grade students and subtract the 9th grade students attending biology? Well, that means we get still 9th grade students that are doing what? That means that they are not attending biology. So here is what this represents. 9th grade students that don't take or do not attend biology. Okay, number 3. We want to write an expression this time. So we're going to go ahead and use the variables to write the expression for a number of students per drinking fountain. So if we think about all the students in the school, and we look at our table, B represents all the boys attending, G represents all the girls attending, we can do B plus G, and there's all of the students in the school. And we can divide that by the number of drinking fountains. What variable represents that? Well, if you look down, we're going closer and closer to the bottom. This third one up, D does. So B plus G divided by D represents the number of students per drinking fountain. Well, there is another way of doing this. We could go through and use H plus V plus K plus E plus Y plus N, because H, V, K, E, Y, and N all represent one gender of each grade. And then we can divide all of that by D. So either of these expressions would work to represent the number of students per drinking fountain. Number 4, we want to write an expression for the number of 9th graders who take seminary. So we're going to go ahead and write an expression for the number of 9th graders. That's what we're going to start with, the number of 9th graders. So remember, if we go up to our table, the 9th grade boys was Y, the 9th grade girls was N, so we're going to add those together. There's our total number of 9th graders. And then we want those that are taking seminary. So let's go down. At the very bottom, S is the number of 9th graders who don't take seminary. So we're going to subtract S. And there's our expression. Number 5, we're going to write an expression for the percent of students who buy lunch every day. Now remember how to write a percent. Okay? A percent is written as the part over the whole, and then we multiply it by 100. So let's look back and make sure we understand what's happening here. Our part is going to be the students who buy lunch every day. So our whole is actually of students, so the number of students. So the total number of students can be represented by B plus G, and the number of students who buy lunch each day is represented by L. So our expression is L over B plus G. But that's the part over the whole. We got to include multiplying this by 100 to get the percent. And there's our expression. Number 6, come up with your own expression and explain what it represents. So go ahead, pause the video, write an expression, and please share it with someone that is around you. It could be a parent or a classmate, but pause the video and write an expression, explain what it represents, and share it with someone. So hopefully you've had the opportunity to share it with someone. Let's go on and look at number 7. What is the difference between an expression and an equation? So we looked earlier, we've written these expressions, and we think about an equation. So let's go ahead. Here's an equation, y equals 2x plus 5. An expression could be 3x plus 2. The difference would be the equal sign. This is the key indicator of whether we have an expression or an equation. So we can say equations have equal signs and something on both sides of the equal signs. Now that's a key thing. We could put an equal sign here next to 3x plus 2, but unless I have something else there, I'm just trying to evaluate it. It's not actually an equation. We're evaluating an expression. Okay, so this concludes the Lesson 2-2 warm-up video for Secondary 1 Math, writing and interpreting linear equations in one variable.